So now that we have a bit of a stronger intuition about not only what it means to speak about algorithm complexity, but also about some practical things like constants do not matter, we are going to go a little bit deeper into how we are actually going to decide what complexity class each algorithm belongs to. So for example, here we have the random min list function and the compute average traversal function again. And let's remember what we did last time. Basically, we followed the trace of execution. Okay, we spoke about that a little bit last time, and we are going to speak in more detail about it now. Let's consider what happens when we are actually running this compute average traversal algorithm. What happens is that, well, we enter this function. Reading a function is something that always takes the same time. Then we execute this, which is an assignment operation. We go to memory, we create the 0 value, and we put it inside of this sum elements function. Usually, atomic operations like this one are always constant time. They all take O of 1. Okay, if I'm not calling another function, if I'm just doing something like adding up two values, doing some other simple arithmetic operator, or just assigning a value to a variable, all of those are always constant time. Then I have a for, okay, a for loop, which tells me about for x in a list. So I'm going to be doing whatever is inside for every element in a list. Okay, let's just keep this in mind and go a little bit further. What I do inside of that loop is just an addition and an assignment. So here what I'm doing is taking the sum elements function, adding x to it, and then assigning it to the sum elements, variable. Okay, so I'm updating a variable. That's an addition plus an assignment operator. So two O of 1, two constant time operations, because multiplicative constants also don't matter. What happens here, inside here, is all O of 1. And then I'm going to return. Return is another of these things that just always takes the same time. I'm going to return whatever is in some elements divided by the length of the list. Okay, so I'm doing a whole lot of things that all take constant time with something that happens once for every element in my list. Okay, so this happens once for every element in my list. This happens n times. So I have something that's constant, plus something that's linear. Okay, because something that takes always the same time times the elements on my list is going to be proportional to the number of elements that I have in my list. Because of that, I have something that's constant time plus linear. In total, the higher order here is linear. All of this algorithm takes linear time. Okay, here you have it a little bit explained in more detail, and I recommend that you do have a read to it.